Mastering the Chemistry Optional, Paper 1 and Paper 2, in the UPSC Civil Services main examination, requires transitioning from generic descriptions to highly rigorous, stepwise technical answers. UPSC demands precise formulas, exact thermodynamic conventions, clear coordination chemistry rules, and accurate arrow pushing mechanisms. Below are 3 highly selected, high-yield solved questions from actual UPSC Civil Services mains trends, representing core pillars of the syllabus: coordination chemistry, thermodynamics, and organic name reactions. Question 1. Inorganic chemistry. 10 marks, 150 words. Question. State the effective atomic number, EAN, rule. Apply this rule to the following 2 complexes: iron 1 cyanide _ 6 carat 4 and iron 1 cyanide _ 6 carat 3, and draw your conclusion regarding their relative stability based on this rule. UPSC previous year question. Model answer. 1. Definition of EAN rule. The effective atomic number, EAN rule, proposed by Sidgwick, states that a transition metal ion tends to accept electron pairs from ligands until its total number of electrons equals the atomic number of the nearest noble gas in its period, which is 36 for krypton in the 3rd transition series. Complexes that obey this rule generally exhibit enhanced thermodynamic stability. The formula is given by where Z equals atomic number of the central metal atom, X equals oxidation state of the metal ion, Y equals total number of electrons donated by the ligands, 2 times text coordination number for monodentate ligands. 2. Application to the complexes. Case 1, iron 1 cyanide _ 6 carat 4. Central metal, iron. Fe, Z equals 26. Oxidation state, Fx. Let oxidation state be X. Electrons from ligands, Y. 6 text cyanidoligands times 2 text electrons equals 12. Calculation. Conclusion. It obeys the EAN rule. Case 2. Iron 1 cyanide _ 6 carat 3. Central metal, iron. Fe, Z equals 26. Oxidation state, Fx. Let oxidation state be X. Electrons from ligands, Y. 6 text cyanidoligands times 2 text electrons equals 12. Calculation. Conclusion. It does not obey the EAN rule. Short of 1 electron. 3. Stability conclusion. Based strictly on the EAN rule. Iron 1 cyanide _ 6 carat 4. Potassium ferrocyanide is expected to be more stable than iron 1 cyanide _ 6 carat 3. Potassium ferrocyanide, because it achieves a stable, closed-shell noble gas configuration. Note, while crystal field stabilization energy, CFSE, and kinetic factors also influence real-world stability, from the perspective of Sidgwick's framework, the 18-electron closed shell makes the Fe2 complex exceptionally robust. Question 2. Physical chemistry, 10 marks, 150 words. Question. At constant pressure, the temperature of a fixed amount of hot tea in a cup decreases spontaneously to room temperature. Predict the algebraic signs, Pm, of delta H, delta S, and delta G for this process. Give sound thermodynamic reasons in support of your answer. UPSC previous year question. Model answer. 1. Analysis of enthalpy change. Delta H, sign, negative, delta H, less than 0. Reason. The cooling of hot tea involves a spontaneous transfer of thermal energy, heat, from the system, hot tea, to the colder surroundings, the room, until thermal equilibrium is established. Because heat is evolved by the system into the surroundings, the process is inherently exothermic. 2. Analysis of entropy change. Delta S, sign, negative, delta S _ text system, less than 0. Reason. Entropy is a molecular measure of randomness or disorder. As the temperature of the liquid decreases, the kinetic energy of the water molecules drops. This reduces their molecular motion and tightens their spatial distribution, resulting in a more ordered liquid state. Therefore, the internal entropy of the T decreases. 3. Analysis of Gibbs free energy change. Delta G. Sign: negative. Delta G less than 0. Reason: the prompt explicitly states that the cooling process occurs spontaneously. According to the second law of thermodynamics, any process occurring spontaneously at constant temperature and pressure must have a net decrease in Gibbs free energy. 4. The thermodynamic balance. Gibbs-Helmholtz relationship. The interplay is governed by the expression for this process to yield a negative delta G, despite a unfavorable negative delta S term, which becomes plus T delta S. The exothermic factor, delta H, must be highly dominant. At high initial temperatures, the process